Hello and welcome to How to Arduino 7, the LCD special. Yes, in this one we're going to cover how to do everything you need to do with your LCD display as long as it's really simple. So what we're going to do is we're going to cover how to hook up the LCD. Then we're going to do a hello world example. And after that, we're going to show how to update the LCD in the loop by having a running time on your LCD screen. This is the 7th in my How to Arduino series. If you are just joining us, then welcome. And if you would like to see the other videos, you can find a link in the description below or in the upper right underneath that little eye. With that, let's jump right into it. All right, so here we are again in Tinkercad. You will notice this time I've already pre-built the circuit. If you are curious how to build a circuit in Tinkercad, please watch the last video where I go into detail on how to use Tinkercad. Now for this one, we have the LCD screen. Normally I would put up a picture of what it actually looks like in real life. However, they did a really good job on this one. It looks exactly like this. So that's what your LCD is. We have a 220 ohm resistor and the 10K potentiometer. You're going to hook it up as shown. I'm not going to walk through it that much. So we just have the rails feeding from 5 volts, so that way we have access to 5 volts and ground. And then if you follow the wiring, it's pretty simple. Just bear in mind that I tried to make everything different colors. So if something is a different color, then it's not going to intersect in the same point. So like this orange doesn't touch anything until it gets over to here, right? So easy enough. The other thing to bear in mind is that we're powering 5 volts to this section, and then the resistor branches over this little gap to come over here. That's just to make things a little bit cleaner. So that's how you hook up the LCD to use it. The next step that we need to do is the coding. As always, the first thing that we'll do is we'll set up our variables to hold on to our pin numbers. So we have the RS, which if you notice, they are all named after the name of the pin. So we have RS, which is register select. We have E, which is enable. And then we have D, 4, 5, 6, and 7. So the RS pin goes to 2. The enable goes to 3, D4 goes to 4, and then to make my life easier, I'm going to copy and paste this. D5 goes to 5, D6 goes to 6, and D7 goes to 7. So those are all of our pin numbers. The next thing we're going to need to do is we're going to have to include a library in order to use our LCD screen. So we're going to include liquidcrystal.h. Liquidcrystal.h is the standard library for using a LCD screen, and it makes our life much, much easier. So we're going to use it. The next thing we need to do is inside of this library, there's a variable type that is called liquid crystal, which is your LCD screen. We need to make one of those. So the variable type is liquid crystal. Once again, this is no different than integer or float or string or any of those. It's just a type of variable. This type of variable happens to be an external LCD screen. That's all it is. So now we give it a name. We're going to call it LCD. And then as part of the rules for the library, when you declare the liquid crystal variable, you have to tell it which pins to look for. So it wants the RS pin, the enable pin, D4, D5, D6, and D7. Now remember, once again, we're just passing it a bunch of variables. Let's get RS, not RD. So the variables that we are passing it are just telling it the pin numbers. So anytime it says RS, it just might as well say 2. And the reason that we're doing this is just to make it easier to understand what's going on, so we can look at it, we know exactly what we're passing it. And then also, if for some reason we decide to change our variables, we only have to change it in one place. If for some other reason we have RS listed like 6 times in our code, we wouldn't have to go through and try to find every single time we used it and type a 2. So that's why that is done. With that, we can go into setup. And inside of setup, we're going to tell the LCD screen to start up. So it's lcd.begin 16,2. The 16,2 is referring to the type of LCD screen that we have. We have one that has 16 columns and 2 rows. So we have a total of 32 characters that we can show. And that just tells the LCD how to work. So now that we've started our LCD screen, let's use it for something. And what we'll use it for is the standard thing for programming. We will tell it to print, which is going to tell it to write it out. And we're going to say, hello world. Because that's your standard programming thing. So we hit start simulation and see if it works. Hey, look at that, it's going. Now you might be wondering what was with the potentiometer, and you might not even be seeing anything. And the potentiometer is our dimmer switch. So you see if it's all the way to the left, it's completely dim. If it's all the way to the right, it's really bright. And they do a good job of simulating an LCD here where you can actually see the places where the characters go. So ultimately, you want to put this right where you can see the characters nicely without seeing too much of the background. So right there would be optimal for standard, but you know, it's yours. You can make it look like whatever you want. So that worked. We put hello world at the beginning. What if we wanted to move it over a little bit? Well, to do that, we need to come back to our code and we need to do something else first. First of all, this is bugging me, so I'm going to fix that. It won't let me. Okay. Oh, hey, I have to turn it off first. There we go. There we go. That was bothering me, sorry. Now, before we do our print, I like leave spaces and things, we need to tell it where to put the cursor. So it's lcd.setCursor. It's a lowercase s, capital C. Then you need to tell it where you want to put it. The way that LCD screens in this library work is you tell it the row, then the column, and everything starts at 0 because it's a computer and that's how they do things. So let's say we want to move it over a little bit. So we'll say we want to start in column 3, and that's going to be in row 0. So that means we're going to move it over 4 spaces. I don't know if that's going to actually fit, but it doesn't matter. We start the simulation, and you see we now scooted it over. So that's how you tell it where to print things. Now, that's all fine and dandy. I wonder, I think if I do 2 here, it might center it. That'd be kind of cool. Yeah, there we go. We'll call that center. Now let's say we want to know how long your program's been running. Okay, so that means we're going to need to have it update. So it's not going to be printed forever. If you want it to show something and just show it all of the time, it's nice to put that into setup so that way you're not calling it every time. We could do this, right? We could put this in the loop, and then if we start it, it works. But this is really inefficient, and that's because every time that it runs through the loop, it's putting the cursor back to this position and it's saying hello world. It's much more efficient to just have it do that one time and leave it. So that is why we don't put this in the loop. We put this up here. And then we have to fix the indentation. Make my code a little bit cleaner. So now let's say that we want it to show on the second row how long the program has been running. In order to do that, we'll have to do it inside of the loop because it's going to be constantly updating. So we'll go into the loop and we will be mad about the way that the tabs happen in this program. And we'll need to set the cursor again to tell it where to write. So we will tell it to write, we'll go for the middle, why not? So we'll go on the 8th character, which is the 8th column, on the 2nd row. As I say that, I realize I'm now actually calling the 7th character or the 9th character because everything starts at 0, which I do forget as well. So we'll fix that, and then this should be exactly centered. Next, we wanted to tell it how long it's been running, I mean. So we need to do lcd.print, and then what are we going to print? Well, we want to print the time that the program has been running. You could do that by adding delays every second and then change it, but a much easier way of doing that is this function that's built into Arduino called millis. Now, this returns the number of milliseconds that the program has been running. So it's since the last time the Arduino was restarted. And so we're going to use this for the most simple function of all, just to print out how long in seconds it's been running. However, it's in milliseconds, so that means that we'll need to divide it by 1,000 in order to get that value. So now we run our program, and we see that it's running. It's at 1 second. Obviously, this is taking more than 1 second. And the reason for that, if you look in the upper left, you have your simulator time. And the simulator time is not running in real time because it has to do all the calculations and run over the internet and do all those things. So as we notice, it's 6 seconds, it's 6 seconds. So they are in unison, they're synced up. That's what we wanted. So this is how you print and use an LCD screen. What I want you to do is I want you to take this setup, and I want you to take any sensor out of the kit that you want, or any sensor that is in Tinkercad, whether or not you're doing it in person or virtually. And then I want you to measure things, and I want you to print out that measurement, as well as a description of what the measurement is, on the LCD screen. All right, so this was a quick one. Now you have your project to do. So thank you for watching, and hopefully I'll see you in the next one.